Dear students, in the previous class I have explained about forward pass. For the purpose of forward pass is to find out earliest starting time and earliest finishing time. In this lecture I am going to explain how to find out latest finishing time and latest starting time. For that, the algorithm which I am going to use is called backward pass. So, the agenda for this lecture is finding latest starting and latest finishing time of activities by using backward pass. Then I am going to explain a concept called slack. The meaning of slack is that many days a project can be delayed that will not affect our total project completion time, that is the meaning of slack. So, what is the backward pass? Let us now continue the algorithm for finding the critical path by making backward pass through the network. Because the expected completion time for the entire project is 26 weeks, we begin the backward pass with the latest finishing time of 26 for activity I. I is the last activity. So, the latest finishing time is 26. So, LS, let LS is the latest starting time for an activity, LF is latest finishing time for an activity. So, then latest starting time is, so latest finishing time minus duration of that activity, that is the T. T is the duration of that activity. Beginning the backward pass with an activity I, we know that the latest finish time is 26, LF is 26 and that activity time is, the duration of that activity is 2 units. So, the latest start time for that activity I is LS equal to latest finishing time, how much? 26 minus duration of that activity is 2. So, 24 is our latest starting time. The following rule can be used to determine the latest finish time for each activity in the network. What is that? The latest finish time for an activity is the smallest of the, okay, that is the earliest time, earliest of the latest start time for all activities that immediately follow the activity. What is the meaning of this? Suppose there are two activity, say like this, okay. Okay. Suppose there is a one preceding activity. So, what we have to do here, we know this is latest starting time, latest finishing time. This is latest starting time and latest finishing time. So, for this activity, so the latest finishing time of, say, assume that this is A, this is B, this is C, it goes like this, arrow is like this. You see, for activity B, for example, the latest start time is say 10. For activity C, the latest start time is say 9. Then the latest finish time for activity A is minimum of this 10, 9, minimum of 10, 9. What is that? So, 9. So, 9 will be the latest finish time of the preceding activity. That is the meaning of this sentence. What is that? The latest finish time for an activity is the smallest of the latest start time for activities that immediately follow the activity. Okay. So, what are the two activities which are following B and C? So, if you want to know the earliest, if you want to know the latest, if you want to know the latest finish time, that will be the smallest of the latest start time of the succeeding activities. Logically, this rule states that the latest time in activity can be finished equal to the earliest value of the latest start time of following activities. Now, I am going to apply this backward pass. So, what is this? 26. Okay. So, this is my latest finishing time for I. So, 26 minus 2 is 24. then it is 24 here. So, 24 minus 12, it is 12. So, when you come here for the activity G, the latest finish time is 24, 24 minus 14 is a 10. Okay. So, for activity F, the latest finishing time is 10, 10 minus 4, it is 6. Now, for activity D, the latest finishing time is 10. So, 10 minus 3, 7. So, for activity F, the latest finishing time is 6, 6 minus 1 is 5, that is latest start time. For activity B, the latest finishing time is 12, okay, 12 minus 6, it is 6. For activity C, the latest finishing time is 12, 12 minus 4 is 8, your earliest starting time. Now, you come to activity A. In the activity A, there are 3 succeeding activity. What are they? A, D and C. Now, you see here, this is earliest start time 5, this is 7, this is 8. So, what is the minimum of, I am writing, what is the minimum of 5, 7, 8? What is the minimum? So, 5 is minimum. So, the 5 will be the latest finishing time for activity A. So, duration is 5. So, 5 minus 5 is 0. Okay. So, now we have the earliest start time, earliest finish time, and the latest start time and the latest finish time. So, now I will explain step by step. So, activity A requires a more involved application of the latest start time rule that I have already explained to you. First, note that the 3 activities C, D, E, C, D, E. So, I will reproduce the value here. I will reproduce the value. So, 26, 24, 24. Rogan, is it right again? Please check this one. Just reproduce this all.
Yes, sir.
Okay. Now, see, the activity A requires a more involved application of the latest start time rule. Latest start time rule. First, note that 3 activities C, D, E. So, the C, D, E, and their latest start times are 8, 7, 5 respectively. So, the latest finish time rule for activity A states that latest finish time for activity A is the smallest of the latest start time for activity C, D, E. So, what is the smallest among 5, 7, 8? So, 5 is smallest. So, I am writing 5. So, 5 minus 5, it is 0. Now, I am going to explain an important concept called slack. After we complete the forward and backward passes, we can determine the amount of slack associated with each activity. What is the slack? Slack is the length of the time an activity can be delayed without increasing the project completion time. So, the amount of slack for an activity is computed as the difference between latest start time minus earliest start time or latest finish time minus earliest finish time. Now, see, for each activity, for example, activity E, the latest start time is 5 minus earliest start time is 5, it is 0. For activity F, so it is 6 minus 6 equal to 0. Activity G, 10 minus 10 equal to 0. Activity I, 24 minus 24 equal to 0. So, activity H, 12 minus 9 equal to 3. For activity D, 7 minus 5 equal to 2. So, activity A, 0 minus 0 equal to 0. Here 8 minus 5 equal to 3, here 6 minus 0 equal to 6. Now, I have found the slack for all activities. For example, activity A, there is a 0 slack, that means this activity cannot be delayed. Similarly, activity E, see, I am connecting all the activities which are having 0 slack. So, here is 0 slack. So, activity F also having 0 slack, activity G also having 0 slack, activity I also having 0 slack. Okay. So, if you connect all the activities which are having 0 slack, so that path is nothing but critical path. Now, for example, say activity C. So, activity C, the latest start time is 8 and earliest start time is 5. So, difference is 3 weeks. What is the meaning of the 3 weeks? So, the activity C can be delayed up to 3 weeks and the entire project can still be completed in 26 weeks. That is the meaning of the slack. You can delay that much amount, but that will not affect our total project completion time. So, in this case, activity C is not critical to the completion of entire project in 26 weeks. So, wherever there is a positive slack, that activities are called non-critical activities. So, next we consider activity E. Here the latest start time is 5, earliest start time also 5. So, the slack is 0. So, what is the meaning of this 0? So, activity E has 0 or no slack. Consequently, this activity cannot be delayed without increasing the completion time for the entire project. In other words, completing activity E exactly as scheduled is critical in terms of keeping the project on schedule, and so activity E is a critical activities. Wherever the slack is 0, that corresponding activity is critical activities. In general, the critical activities are the activities with 0 slack. So, with the help of the previous network problem and by using forward and backward pass, I have found the earliest start time and latest start time and earliest finish time and latest finish time. So, what is the slack? Latest start time minus earliest start time 0, 6, 3, 2, 0, 0, 0, 3, 0. So, wherever the slack is 0, so I am writing that path is critical path. What is the critical path? A is there, the next one is E, the next one is F, next one is G, next one is I. So, A, E, F, G, I is our critical path. So, see this A, E, F, G, I, this is our critical path. So, what is the contribution of this PERT and CPM for the managers? We previously stated that the project managers look for procedures that will help answer important questions regarding the planning, scheduling and controlling of the projects. Let us consider these questions in light of the information that the critical path calculations have given us. The first question that the manager is wanted to know, how long will the project take to complete? It is a very obvious question. So, the project can be completed in 26 weeks, because you see that this 26 weeks, here also 26 weeks, if each activity is completed on schedule. That is the answer for this question. The next question, manager want to know what are the scheduled start and completion time for each activity. So, this table shows the earliest start, latest start, earliest finish and latest finish time for each activity. The next question manager want to know is which activities are critical and must be completed exactly as scheduled to keep the project on schedule. So, what we have to look at from this table? We have to look at wherever there is a 0 slack. So, that corresponding activities are called critical activity, that should not be delayed at all. So, what answer we have? A, E, F, G, I. The another question manager may want to know how long can non-critical activities be delayed before they cause an increase in the completion time for the project. So, here we have to look at the column where the slack is there. So, for example, activity B can be delayed 6 days, activity C can be delayed 3 days. You should be very careful. At a time you can delay only for one activities. You cannot simultaneously delay activity B and C. So, the here slack the meaning of slack is by keeping all other duration of activities, the schedule of the activity same, you can delay only the activities of say B. What is the meaning of that? The other activities are not delayed, only one activity delayed at a time, that is the meaning. Now, what are the summary of the PERT CPM critical path procedures? Step 1, develop a list of activities that make up the project. So, we have to identify what are the activities that form our project network. Step 2, determine the immediate predecessors for each activity in the project. So, we have to find out what are the predecessors. Okay. Step 3, estimate the expected completion time for each activity. Sometimes this expected completion time may be deterministic, that means only one value may be given. Sometimes there may be 3 value. What are the 3 values? Optimistic, pessimistic and normal time. Okay. The step 4, draw the project network depicting the activities and immediate predecessors listed in the step 1 and 2. Next you have to draw the activity. Step 5, use the project network and the activity time estimates to determine the earliest start and the earliest finish time for each activity by making forward pass through the network. The earliest finish time for the last activity in the project identifies the expected time required to complete the entire project. We have seen that value is 26 for example. Step 6, use the expected project completion time identified in step 5 as the latest finish time for the last activity. Then make a backward pass through the network to identify the latest start and the latest finish time for each activity. So, by fixing the latest finish time for the last activity, from there we have to use the backward pass to find out the latest start time and latest finish time for all the activities. Step 7, use the difference between latest start time and the earliest start time for each activity to determine the slack for each activity. What is step 8? Find the activities with 0 slack. So, these are the critical activities. Step 9, use the information from step 5 and 6 to develop activity schedule for the project. So, we might have got the value by using forward pass and backward pass. By using that information, we can prepare the schedule for each activity. What we can prepare? Earliest start time, earliest finish time, latest start time and latest finish time. Now, I have taken another problem. I am going to follow these steps in this problem, then I am going to explain the forward and backward pass. So, IIT Roorkee is undertaking a summer renovation for its main building. The project is scheduled to begin May 1 and the September 1 completion date is desired. So, how many weeks between May 1, May, August, September? There are 17 weeks. So, the renovation has to be finished within 17 weeks. The contractor identified the following renovation activities and their estimated times. So, there are 3 activities A and B, C, there is no predecessors. For D there is a predecessor ABC, for E also there is a predecessor CD, for F also there is a predecessor A, for G also there is a predecessor D and F, for H there is a predecessor E, and the time for each activity is given. So, as per the steps, the first step is the questions which you have to answer is draw a project network, what are the critical activities, what activity has the most slack time, will the project be completed by September 1? These are the questions. The first one, we have completed step 1, step 2, step 3. What are they? Develop list of activities, determine immediate predecessors, estimated expected completion time, that we have completed. Now, we will go to step 4. Step 4 is drawing the project network. So, we start from here. There are 3 activities, there is no predecessors. So, A, B and C, duration 3, 1, 2, 3, 1, 2. This is start. Then for activity D, there are 3 predecessors A, B, C. Okay. So, I am going to draw the activity D here. So, the predecessor for activity D is ABC. So, A, B and C. For activity E, C and D is the predecessors. So, here I am writing activity E. The predecessors are C and D. Then activity F. So, for activity F, I am writing the predecessor is A. So, here I am writing so the predecessor is A. Then for activity G, the predecessor is D and F. So, D and F. Okay, for activity H, the predecessor is E. So, activity H, the predecessor is E. Okay. So, we have drawn the project network. Now, we will go to step 5. Step 5, estimate earliest start time and earliest finish time using forward pass. I am going to use the forward pass. So, wherever there is no predecessors, the earliest start time is 0. Here it is 0, here it is 0, here it is 0. So, earliest finish time is earliest start time plus the duration of that activity 0 plus 3, 3, 0 plus 1, 0 plus 2. Now, for activity F, the earliest start time is equal to the earliest finish time of the preceding activity, that is A. So, it is 3. So, 3 is earliest start time. So, this 3. So, 3 plus 3 is 6. Now, you see for activity D. For activity D, there are 3 earliest finish time. What are they? For activity A it is 3, for activity B it is 1, for activity C it is 2. So, we have to find out the maximum of 3, 1, 2 in the forward pass. The maximum is 3. So, 3 will be the earliest start time for activity D. So, 3 plus 4 it is 7. So, here it is a 2 plus 5. So, now for activity E there are 2 predecessors. What are they? D and C. Which is the largest value of their earliest finish time? So, between 2 and 7, 7 is the largest one. So, 7 will be the earliest start time. So, this will be 12. Now, 12 it is 16. Now, it is 7. Now, you see why it is 7? Because for activity G there are 2 predecessors F and D. The earliest finish time for F is 6, for D is 7. So, which is the highest one? 7. So, it is 13. Now, I am going to estimate the latest start time and the latest finish time using backward pass. So, what I have to do? I have to start from 16. So, 16 is my latest finish time. So, 16 minus 4 is 12, here it is 13, 13 minus 6 is 7. So, here it is 12, 12 minus 5 is 7. So, for activity F it is 7. So, 7 minus 3 is 4. For activity D it is 7, 7 minus 4 it is 3. Now, look at the activity A. There are 2 latest start time. What are they? 4 and 3. The largest value is 4, the smallest value is between 4 and 3, the smallest value is 3. So, 3 should be written. So, 3 minus 0, 0. Now, this is 3 for activity B, 3 minus 1 it is 2. Now, for activity C there are 2 succeeding activities D and E. There are 2 latest start time 3 and 7. So, which is a minimum? 3 is a minimum. So, 3 minus 2 it is 1. So, now I have completed the latest start time and the latest finish time. Now, the step 7 and 8 is determining slack time for each activity and finding critical activity. So, we know what is the slack? Slack is the latest start time minus earliest start time. So, here the activity A is having 0 slack, activity D is having 0 slack. So, activity E is having 0 slack, activity H is having 0 slack. Okay. Now, wherever the slack is 0, that activities are called critical activities. So, what is a critical path? We can say the critical path is A, D, E and H. So, when you go back this route A, D, E H. So, this E, then it is H. So, this route A D E H, this route is the critical path. So, the duration is 16. So, in this class I have explained how to find out the latest start time and the latest finish time using the backward pass. Then I have explained the meaning of slack of each activity. Then I have developed a project schedule. Then I found the critical path. So, I have taken one sample problems. I have explained all the concepts with the help of that sample problem. Thank you.